Okay, so the last thing in this chapter, which basically is dealing with the units used in measurement in science. So we've talked about grams, and we've talked about liters, and we've talked about seconds. We haven't really talked about the mole, but we'll get to that. But we've talked about all these different units in science that we use. The last one we have to talk about is temperature. Okay, so temperature, I know you're all very familiar with the Fahrenheit system, that water freezes at 32 Fahrenheit, boils at 212. 70 degrees Fahrenheit is a comfortable day, that kind of thing. 95 is a little bit on the hot side. Well, now we're going to talk about how to relate Fahrenheit to Celsius, okay, because Celsius is the numbers we use in here. Celsius actually is a little bit better of a scale in the sense that water freezes at 0 and boils at 100, and everything else is based off of that. That's how they scaled it, okay. There is a relationship between Fahrenheit and Celsius, and these are the two equations. You can use either one. It's just a matter of what you're given. I would use this equation if I was given degrees C, because I would just plug it in there and multiply and add. And I would use this one if I'm given degrees Fahrenheit. Now, do you have to memorize these? No. We will give them to you. You need to know how to use them. In particular, you need to make sure that you understand that that has parentheses around it. You need to follow the PEMDAS rules, right? Please excuse my dear Aunt Sally. Parentheses first, before multiplication. Okay? And then we also talked about the official SI unit in science is kelvins for temperature. We'll deal a lot more with that when we get to gas laws, but for right now I'm just going to show you the way you calculate it. Is you take the degrees Celsius and you add 273 to it. So kelvins is based on what's called the absolute scale. What it did is they used math, they used gas law measurements, and they calculated what is theoretically the lowest possible temperature, and they called that 0 kelvins. Nothing gets colder than that. Okay, it's about negative 273 Celsius, and it's about negative 400 and something Fahrenheit. So it's pretty darn cold. But what you need to know is how to convert between them, and so all you do is take whatever the degrees Celsius are and add 273 to get kelvins. It doesn't use a degree symbol either. It's kind of weird. And like I said, because Kelvin is such an easy calculation, you're going to need to be able to know that. I will give you Fahrenheit, both of the Fahrenheit equations. So basically, I'm just going to have you go through and we're going to fill in this table. So take a minute, pause the movie, write down what's in here, and then we're going to go through and fill in the blanks. Okay? All right, so let's remember our equations. So to find degrees Fahrenheit, we take 9 over 5, or 1.8, multiply by degrees C, and add 32. To find degrees C from Fahrenheit, we take 5 over 9, and we multiply by the quantity of the Fahrenheit, subtract 32, but the parentheses are very important. So for the first one, to turn 92 into Celsius, I'm going to put 92 in here, so I'm at 5 over 9 times 92 minus 32. So I'm going to subtract first and get 60. So I have 300 divided by 9 for my temperature, and it's 33.3. In terms of sig figs, don't sweat these. I'm not going to worry about sig figs. Let's go the opposite direction. I'll deal with Kelvin last because that's the easy one. I'm giving you 100 degrees Celsius, so I'm going to use this equation. Okay, so I have 9 over 5 times 100 plus 32. And in this one, you want to follow PEMDAS rules. There's no parentheses. So multiplication comes first. So it's 9 divided by 5 times 100, then add 32. And you should get 212. Okay? Go ahead, practice this one. Again, you're going from Celsius into Fahrenheit. So 9 over 5 times 37.5 plus 32. And the addition is the last part. So 9 divided by 5 times 37.5, then add 32. 99.5. That's about body temperature. It's a little bit on the high side. Okay, and I'm going to do this negative 40 before I do the Kelvin one. Negative 40, I'm giving you Fahrenheit. That means I'm going to this equation. I'm giving you the Fahrenheit. So 5 over 9 times negative 40 minus 32. Okay, again, do the parentheses first. Negative 72 times 5 divided by 9 is negative 40. This is where the two temperature scales intersect, is at negative 40. They both have the same value. Okay? All right, let's do this, the Kelvin ones. Remember, to do Kelvin, all you do is take degree C and add 273. So this would be 33.3 plus 273 is 306.3. Add 273 here, you got 373. Add 37.5 plus 273, 310.5, and this will be 233. Okay, so that's relatively easy. Going this way, if I add 273 to the Celsius to get the Kelvin, to get Kelvin into Celsius, I subtract 273. That would be 0 in this case. And if that's 0, and I put 0 in here, I have 9 over 5 times 0 plus 32. Well, 9 divided by 5 times 0 is 0. Add 32. That's the freezing point of water. Okay, so like I said, I will give you those equations. This one you are responsible for, but it's basically just make sure you follow PEMDAS rules and pay attention to what you're dealing with.